Hello to everyone. One of the most important things when we are implementing a spatial database in MySQL is that the stored spatial tables be interoperable. And what this means, the interoperability. The interoperability of a spatial table, it is the capacity of this type of tables in communicate without any restrictions with different systems or products. That is, when a user stores a spatial table in MySQL, he wants that it can be opened in different applications of geographic information systems, with the ability to read and write. It is possible to have this interoperability in the MySQL database? Yes, it is, and I'm going to explain how in this video. The interoperability of a spatial table is the ability of this type of tables to be opened by different products of geographic information systems, with the capacity of read and write data. To show how this works, I am going to do a little demonstration. So, I open the MySQL workbench, and as you can see, I have a default schema with the name Spatial Test, and inside this schema I have a spatial table with the name test_QGIS. This table it's prepared and configured to answer to the various requirements asked by the different GIS software that I'm going to use. Moving forward, I will launch the Manifold Release 9, a proprietary software. Then I start a project that has a link to the MySQL database, and after I open the test_QGIS table. Now, I launch the QGIS version Pi, an open source software. Then I link it to the MySQL database, and I open the test_QGIS. As you can see, the same spatial table it's open on 3 different applications. The question is, can I work on this table like this? Let us see if it's possible. First, inside the Manifold Release 9, I will draw one object and save it. Everything went well. Then, I open the QGIS Pi, click the refresh button, and the object that I drew on the other software is there. Now, inside this application I will do the same, draw another object. As you can see, the object has been successfully saved. If I return to the Manifold Release 9, and refresh the view, the object that I drew inside the QGIS is there. Now, inside the MySQL workbench, I refresh the table and here is the data that I have added to this table from the GIS software. And I can also edit or populate the data from this application. And if I go to the QGIS or to the manifold release 9, the changes are there. With a system built like this, where the spatial tables are interoperable, in a little network office, I can have 2 or 3 users on different software packages, working in the same spatial table. If I want to use the MySQL database to store my spatial tables in a way that different GIS software can use that spatial tables correctly, there are 3 requirements that I must consider, and these requirements are related with the Coordinate Reference System, or CRS, and the needs of the software that I may be using. So, let's see what those factors are. The first requirement is the Coordinate Reference System. This is a requirement requested for all software used on a geographical information system. The CRS must be well read and interpreted by all software that I may be using. This means that all the parameters that are used to build a coordinate reference system must be equal in all software involved in my geographic information system. Fortunately, the most recent software can use the standard Spatial Reference System identifiers from the European Petroleum Survey Group, or EPSG. As you can see in this table from the MySQL database, with the name st_spatial_reference_system, it stores all the SRIDs created by that group. If I open a spatial table in the manifold release 9, a proprietary software, as you can see it uses the same spatial reference system identifiers from the EPSG. And if I open another spatial table in the QGIS Pi, an open source software, it uses as well the same SRID from the EPSG. This universality is a guarantee that all programs are using the same language, in what concerns about the coordinate reference system. Resuming, when I am writing a script to create a spatial table inside the MySQL database, I must always to add the SRID constraint. This is fundamental. The second requirement is the spatial index. This requirement is usually requested by proprietary GIS software. In a few words, a database index is used to improves the speed of the operations and to quickly locate data in a database table. For non-spatial data, the database engine creates a B-tree indexes. However, the binary tree index is not efficient for spatial data type, like geometries. So, for a spatial column data type, I must have an R-tree index. This type of index it's used for multi-dimensional data, like geographical coordinates. And to create an R-tree index, I must add a spatial index to the spatial column. Let's do a little demonstration about this. Inside the manifold release 9, I open this two drawing tables, the test_M9 and the test_M9 noindex. The first one, the spatial column, has a spatial index and the second one has no index. Now, I'm going to draw an object in both spatial tables. As you can see, in the first spatial table everything is fine. However, the geometry that I drew in the second spatial table, the one without a spatial index, is not visible. This is a consequence of the index not being present. Now, I'm going to open the table, with no spatial index, inside the QGIS Pi. As you can see, the geometry that I drew from the manifold release 9, it's visible. And why? Because this open software does not require a spatial column with a spatial index. Let's go forward to the third and final requirement, the geometry_columns table. In a few words, the geometry_columns is a standard table that you can find in all relational database management systems. This table provides support for coordinate reference systems, for GIS software. However, the MySQL database works with the st_geometry_columns. This table is based on the standard geometry_columns, but with extensions, as noted. When a user adds to the MySQL database a table with a column spatial data, automatically it populates the st_geometry_columns with the spatial information of that table. The problem is that the open source GIS software can't read the information stored in the st_geometry_columns. The solution, it's to add the standard geometry_columns table to the schema where the user has the spatial tables stored, and after, populate the table manually. For more information about this, see my video stored in this channel with the name, What is the geometry_columns? After this little explanation, I'm going to do a short demonstration about this. So, I have this two spatial tables with the names test_ggis and test_gisdemo. The first one, it's registered in the st_geometry_columns and in the geometry_columns. The second table, it's registered only in first table. Now, I open the QGIS Pi, and then the two spatial tables. Then, I'm going to draw an object in both spatial tables. As you can see, in the first spatial table the object has been successfully created and saved. However, the geometry that I drew in the second spatial table, the object has been unsuccessfully saved. This happens because this table has not been registered in the geometry_columns table. Now, if I open the table test_gist demo, inside the manifold release 9, I can read and write it, with no problems. And why? Because this software can read the spatial information of the table that is stored in the st_geometry_columns table. As you have seen in the previous step, different software, different requirements. So, when I create a spatial table and I want it to be used by different software, I must prepare it in a way that could answer to the different requirements requested by each software. To do a little demonstration how to do this, add interoperability to the spatial tables. Inside the MySQL workbench, I'm going to use the two ones that I have used in the previous step and that haven't worked in both softwares, the test_m9 noindex, that haven't worked correctly inside the manifold system 9, because the lack of the spatial index, and the test_gist demo, that haven't worked correctly inside the QGIS because is not registered in the geometry_columns table. First, I select the test_m9 noindex and then I enter to the info mode of the table. Then I click on the index tab, and I follow the steps to create the spatial index for the column that stores geometries, the one named shape. And that's it, this table has now interoperability. Secondly, for the test_gist demo table, I create a script inside the SQL query tab, in a way to populate the geometry_columns table with the spatial information of the test_gist demo table. See more information how to create the script in my video with the name, What is the geometry_columns? After running the script, this table becomes interoperable. I hope this video is illustrative on this matter, the interoperability, and that it helps you in your work.